Hello everyone, welcome to my channel iTechShare, a channel where we can connect, discuss and share anything and everything on this IT industry. Today's session is on microservices where we will discuss about the overview of the microservice ecosystem, where to use, how to use and what are the things you need to know for going ahead with microservices. And I hope that post this session we'll have a better understanding about the microservice ecosystem. So let's get started. So what is microservices? I mean, as the name suggests, microservices, right? So that means that is in a combination of various small service components. Earlier we are in a situation where we had kind of a very large service which was doing everything by its own, right? Adding, deleting, updating, querying, everything through that service. So now with this microservice ecosystems we are doing the same thing but in a different way. We are splitting those functionalities or features in different services, service components rather, and then we are making those things in an independent and autonomous way so that it can be highly maintainable and testable. So overall, I would say this is a as the first point I have mentioned over here, this is the collection of multiple service components. And one very important point here, this is not related to any kind of s- specific computer language. Like today maybe you are a .NET guy or Java guy, that's not a big deal, right? Whenever we are going ahead with writing some kind of microservices, what you need first, the concept, and it's technology independent concept. So there are few other very important things that you need to keep in mind while solutioning microservices, like scalability. So this is one of the most important thing. I mean, your microservice should be able to scale up or down depending upon the loads. So there are various systems to achieve that through containerization using Docker or Kubernetes, and that we can discuss in some later sessions. Um, Similarly, we also need to think about resiliency. I mean, how fast you can bring back to that track if any downtime happened. And there are some design patterns you need to follow, like circuit breaker or some other approaches are there. Also, we can discuss those things in detail in some separate videos. uh, Along with that, most important things I would say here, that domain driven design, because all this microservice solutioning actually built on this domain driven design. You have to figure it out, right? That what is the domains for your microservices. Domain means the business boundary context as a whole, if I can say. For example, if we are going to build some kind of an e-card solutions, and then payment is kind of an a domain for you, then ordering kind of an other domain for you, then inventory, that can be another domain for you. So the different areas specifically you can focus through those microservices. So that's the reason, first when you will get the requirement, you need to first identify the domains, and depending on the domains, then you can take a call how many microservices you need, and what are the business behind those microservices, because those things will be driven by the domains. So now let's discuss about the architectural differences between a monolithic, that means the traditional um, approach, and a microservice approach. Okay, so now you can see on the screen that we are having a monolithic architecture in place, where EY, business layer, data access layer, and DB, all these things being developed, very tightly coupled way. That means that you can't able to separate it out from the code base, and everything is being integrated so tightly, and also it's only deployable in one specific server, or maybe max two servers, right? So now down the line you want to make any changes in your business layer or data access layer or DB, you need to make the changes throughout those all layers to get it done. Now have a look on these microservices architectures. So if we'll split these same things in microservice architecture, you can see these are being now splitted between several microservices, right? I mean, our services, the main service now have three additional services. I mean, not three and more, MS1, MS2, and let's say MSN. And each service component having their own database in it. Okay, so that means your one microservice coupled with one DB can be deployable to one container through Docker or Kubernetes, and the UI is different. Everything now can be talked through these microservices, right? Through this gateway. Now, time for us to look into one case study, and from that problem statement that we get from here, how to approach for the solution. So, let's focus on the problem statement. What is the problem statement? Here, let's imagine that you need to build one e-commerce site which will having offer for CD, media and ebooks and several items. It should able to cater 1 lakh plus customers to various channels, and the main thing is that your system should be scalable and resilient because so much of users you need to support. Some of the features it should have like search, order, buy products, typical any e-commerce product should have. So with all this initial information, let's deep dive into our next step, that is identify domains. If you remember at the beginning we have talked about this, that domains are the main things for any microservice design patterns. From here you have to decide how many microservices you need to build. Two types of domains we need to consider. One is the functional requirement, I mean the domains driven from the functional requirements. The second are from non-FR, I mean non-functional requirements. So the problem statement that we have discussed, if we can see that, I mean from here we can achieve search, cart, payment, product, notification, wish list for any e-commerce, right? So those we can consider under FR, functional requirements, and non-FR, I mean NFR, non-functional requirements. Under that we can consider the like performance, scalability, security, availability, testability, monitoring, all these steps. Okay, so let's wait and watch. So with all this understanding, now if we'll move ahead with this microservice architecture, so finally it will looks like this. So here you can see that we are having lots of microservices like search, cart, wish list, along with their own dependencies, and it may be some database or Elasticsearch or any alerting mechanism or anything, right? So main objective here that every microservice you can see, let me just move to this pointer here. So you can see, right? So this is a search microservice, this is a cart microservice, and then if you can see that this microservice is separate from the other microservice. Similarly, all these microservices are separated from each other, right? And why like this? Because we can deploy each microservice separately in a different pod, and that's why there will be no dependency between these microservices. But one important fact over here, that there is a mechanism we need to be here to talk between these microservices, and that's why we are having this message broker, right? And this message broker is important to orchestrate between multiple microservices. So you can have your message broker built on a RabbitMQ or Kafka, or you can have your own orchestration system also in place, but this is the overall picture it will looks like. So before I'll conclude today, few things I want to share with you. So now you can go ahead and look into the REST API implementation approach, because whenever you are building any microservice, you have to build it on the REST API approach. Second thing, you can also look for some of the documentation. Those are available in Microsoft site. Those are very, very useful cloud specific microservice architecture oriented documentations are there, and very detail oriented, very useful. Third thing, you can also look into on the containerization process through Docker and Kubernetes. There are so many materials available over the net, and probably I'll also share something down the line, but it will take some time because I need to get those things in the Azure and set up and all this stuff. So okay, for now it's fine, and be safe, and thanks for your time. Happy learning. We'll meet again. Thank you.